So my name is Phil Newman. I run marketing for Metacarpal, and we're joining today to talk about the Metacarpal Gem. So thanks so much for joining us. We have a Q&A panel in the Zoom window. So we're going to be talking about a lot of very interesting things today. So please pop your questions into the Q&A and we'll address those as we get to the end of today's call. Now, we consider that Metacarpal Gem really represents a next evolution of prosthetic hands, driven by the control of the user's natural body movement. Metacarpal Gem is waterproof, doesn't require complex control systems, provides long-term reliability, and we really consider it's great for both prosthetists and the care team, you guys. So we'll talk with one of our users in just a moment, but we consider that obviously Metacarpal Gem has multiple grip options, provides less fatigue for the users, obviously enhances those ADLs, and part of that is the proportional pressure feedback that the system provides. So don't take my word for it. We're joined by Garrett, who's one of our first users. Hey, Garrett, how are you?
I'm doing good, sir. How are you?
Yeah, great. Well, Garrett, last time we spoke, you were just about to launch into doing a blue and white striped bedroom for your son. How did that go?
It turned out amazing. It looks so good. My son, we're both my older boy said he wants to paint his house like this.
Great. So, Garrett, thanks so much for taking time to join us in your lunch break today. Tell us about your story, Garrett. I'd love to learn a little bit of how you arrived where you are today.
So I was working on a farm 13 years ago in central Indiana, and I was doing some custom fabrication and steel building, and one of the grain augers got plugged up. The auger is basically a screw inside of a pipe, moves the corn material from point A to point B. Well, it got plugged, so me and the boss went over. We got everything cleared up, but there was a small inspection door about 6 by 8, and I was going to put the inspection door back on, but I was down on one knee and I was balancing myself with my left hand trying to install the door. And when I turned to Larry to tell him to shut the machine down, my hand slid just a little bit and it severed my thumb, my middle finger, and then it ripped my hand just above the wrist and also split down my wrist. Wow. It was a pretty clean, quick cut. I consider it the best, worst day of my life. I nearly bled to death, but luckily there was a young soldier on my crew that did a double tourniquet and stopped the blood loss. I nearly did bleed out. I lost 8 pints of blood and had to have a full transfusion.
Wow.
They airlifted me to Indianapolis, where the doctor told me they were going to put my hand back on. I laughed at them, and they sent me to the other side of the room where I took a quick picture of my hand sitting on a towel. I woke up the next day and I could smell the necrosis, the flesh dying. And I told them something wasn't right. So they opened the bandages back up and they realized that my index finger had died. So they removed it. So that left me with just my pinky and my ring finger with severe trauma. I had around 1,500 stitches in just my hand.
Wow.
And so after about 2 months of physical therapy, the doctors wanted to remove a toe to try and build me a thumb. And I opted out of that, and I had it amputated for a second time.
Wow. Well, Garrett, obviously that's a very traumatic story, and our best wishes to you back in those days. But of course, you're a very positive person, right? And you've been through quite a lot of devices. You're now wearing the Metacarpal Gem. So tell us about that experience. I mean, it's great to see it on you today. You're at work, doing construction, but how does that figure into your everyday life now?
I've found many uses with this hand. I've been, like you said, I've been through many devices. I've had many body power devices, which I really enjoy. They're very dependable. With my trauma from my accident, I have a lot of muscle spasms and phantom pains. So anytime I put on a myoelectric, I've got to deal with, uncontrolled muscle spasms where the hand will just open and close and it changes grips. I also burn through the batteries very quickly. They say that they would last up to 8 hours. I found they really only last about 4 hours with steady use. And then also, the batteries are very bulky. I was invited to a gala recently, and it was a suit and tie event, and I wore the bionic hand because it's kind of a classier, I guess, in a way. It looks, everybody thinks it's fancier. I personally would rather wear my hook or a body power device, but the bionic hand, I wasn't able to put on my nice dress shirt. I wasn't able to wear my suit jacket to fit comfortably. I was just very uncomfortable wearing it the whole time. I've had a
Yeah.
lot of issues with suspension where my dream is to be able to do push-ups and pull-ups while wearing my prosthetic. I basically want to be a bionic man. I had my doctor build it so tightly that we had to cut it off of me. In the office, we had to get a saw to cut the prosthetic socket off of me.
Wow.
Um, so we made a few minor adjustments, and we have it, somewhat working, but I still have the issues of muscle spasms, the bulkiness, the batteries dying. I can't get wet. I can't get it dirty. The media connection is always a very weak point where the hand screws on, and I've broken multiple. I think this is my 13th myoelectric device.
Wow. Wow. So that's very interesting because obviously, Metacarpal Gem has got the multi-articulation of the fingers. You
Right.
sound like you're more of a committed body-powered user. So tell us about how you're using the device. You and I were talking about putting socks on the other day. So how's it going
Yeah.
with your activities of daily living?
It's amazing. Like cutting a steak has always been a big struggle for me. People offer to do it, to cut my meat for me, and I try to be as respectful as I can, even though it usually is very frustrating. I'll just grab that whole steak and just eat the whole thing before I spend my time with a knife and a fork. But with the
Yeah. Yeah.
metacarpal, with the gem hand, I just put the thumb into the right position here, and I can grip the fork. I can hold the knife. I don't have to worry about my plate sliding off the table or the countertop. Everything stays right stationary where it's supposed to be. Like you said, putting on socks is, once you get down to that reaching point of below the knee with any body power device, it becomes a little bit more different. But once, I guess, with all my years of experience now, I've learned to keep that proper pinch. Whereas then the myoelectric, I can't control the sensors. My arm doesn't seem to fit into the socket properly. Open and close becomes completely involuntary, and changing grips. So it makes it nearly impossible. I tend to get frustrated and just throw that myoelectric hand back into the closet where I usually leave it.
Right. Yeah. Great. Well, Garrett, I know you're on your lunch break, so let me just ask you one more question before you bounce. So, how is it going in terms of your daily use? Because I guess it's kind of like one of the things that Metacarpal Gem and the system provides is, very easy glide. We see that there's less fatigue with other users. How often, in terms of the day, and how many hours a day are you using the device now?
I can wear this thing 10 to 12 hours a day. I typically work a 10-hour shift as a construction worker. I'm operating heavy equipment, in a trench with a shovel. I'm climbing up ladders. Just the other day, I was climbing up the side of this steel building to set a beam and show the guys how these things need to be done. But I also have to remind these guys that they can use both hands. They don't have to be like me and just do it one-handed.
Yeah,
But
great.
I
Well,
mean, everyday living has been great. With the myoelectric, typically my arm, the muscle spasms from trying to open and close all day long. I get so much fatigue that the muscle spasms just get intense and get worse. I get very uncomfortable. I get very frustrated with the body power device. It's so dependable that it opens when I want it to open. It closes when I want it to close. And like I said, I can wear this 10 to 12 hours a day, and I don't even get the discomfort in my other armpit here that I usually get from my hook. The one hook device that I wear is solid steel, completely welded. It's basically a sledgehammer on a harness.
right.
And
Yeah.
yeah, it weighs 15 pounds. You know, I think this thing weighs altogether with socket and harness somewhere around 3 or 4.
Right. Yeah.
So I don't get that discomfort in the end of my limb right here. I don't get the discomfort in my neck muscles or the underarm area. Normally, I would have to put like a rag or some type of a sponge to kind of create space where it gives me more comfort. But with this hand, I don't have to. I can just use my regular old harness. This is the harness off of one of my old body powered systems
right.
that is kind of just temporary at the moment. But I just got a message from my doctor this morning that everything's been approved. My insurance is going to allow me to buy this Metacarpal Gem hand, and I get a whole new socket, harness, the works.
That's great to
I'm
hear.
really excited to have one that works and functions
Yeah.
as it should.
Brilliant, brilliant. Well, Garrett, really, thank you so much for joining us today. Thanks for squeezing us in on your lunch break.
My
We're
pleasure,
gonna
Phil.
move on now. So, Garrett, if you need to go and eat some food, please, please do so. Right.
I got my Lunchable right here.
Awesome. Thanks so much for joining us, Garrett. Really, really, really appreciate it. So
My
we're going
pleasure.
to move on now to have a conversation with Fergal Mackey. He is the CEO of Metacarpal. He's also the originator of the technology. We're going to go through some slides with Fergal. He's going to talk to us about the details of the product. So Fergal, are you ready to go?
Yep, ready to go.
Great. And just before you do, Fergal, I see that there's been a hand raised by Emily Schmidt. So Emily, if you don't mind using the Q&A panel at the bottom, we can then answer your question as we go along. So perfect. Fergal, over to you.
Perfect. So as you'll all know now, and most of you hopefully knew already, I'm the founder, CEO of Metacarpal. We really exist because of the extremely low acceptance rates in upper limb prosthetics, and it's our mission to meet those that currently aren't being served by prosthetics development. And so to solve this, the industry has centrally looked at myoelectric and predominantly multi-articulating hands, and they have made huge advancements, which is working for a lot of people. But what we often hear is that there's an equally large group of people that this technology isn't working for. And if you belong in that group, then prosthetics really hasn't changed in about 100 years. So it's essentially around issues of weight, cost, and reliability, but ultimately they're impractical. And compared to the other side with the body-powered devices, hooks, they're incredibly practical, but as I say, haven't changed in about 100 years. And this, we feel, creates an enormous gap. And it's that gap that users are falling into. And centrally, what we seek to fill with Gem. Essentially, we're pairing the features that make myoelectric devices so desirable and pairing that with the practicalities of body-powered control. And we make that possible through a variety of technology that we've developed to create this new generation of prosthetics with body-powered multi-articulation. So the first issue for any body-powered hand, if you guys have experience with that, is often just the force to operate them. So importantly, Gem requires 3 to 6 times less operational force than comparable hands. And crucially, that's below the fatigue limit for the average female user. Then we pair that with the multi-articulating features. So first off being adaptive grasping, thanks to our patented reactive body-powered system. So the fingers will conform around any object, giving a secure grasp at even lower forces. And that all happens automatically without any added complexity for the user. And as well as this, you're able to switch between different grips, the 3 major grips, pinch, lateral, and power, allowing for a greater scope of functional abilities than you would with a hook. And then we pair that with the practicality advantages associated with body power, mostly that they're just worry-free. They're inherently durable, waterproof, and reliable, and we've kept that alongside proprioception so that you have instant function that you can feel. So it's a hugely important factor, and you'll see some of that in the videos that I'm just about to show you. So the first here, you can see an example with a body powered hook, and you get that instant operation and that proprioception. But what you might see is that the hook isn't the ideal tool for every task. And because it's not able to switch between those, it's almost stuck. Then if you compare that to, say, a myoelectric device, where you have the right tool for the right task, but controlling it isn't always that reliable or easy, as you'll see here where that happens. And then finally, I'll compare that to Gem. This is an older prototype, but where you've got the right grip for the task in hand, and you get immediate operation and proprioception, you're able to do things inherently. And this user's only had that device on for about 30 minutes before he started to do that task. So if I do go for a more direct comparison here, when it comes to function, we pair the features that users really need with that proprioception for the first time in prosthetics. And we do that without sacrificing durability and dependability. And we feel that's really how you increase trust in prosthetics, and that's what's really going to increase prosthetics acceptance worldwide. So I'll now pass you back to Phil, who's going to introduce the next guests.
Great, thanks, Phil. Well, obviously, I'm sure there are going to be some questions as we get through. Just a reminder to everybody, please do put your questions in the Q&A panel at the bottom. So we're now going to be talking with Erica Carlson, who is our US National Sales Director, and Tony Gutierrez, who's the Director of Clinical Advancement and Innovation at Bionic P&O. And also, Tony, you're Garrett's prosthetist, right?
Yes, I am. So I've been on his journey watching him break everything for several years.
Great. He's a great guy. So over to you guys.
Perfect. Well, it's good that he's got somebody like you on his side to help him along the way, and we're super happy to introduce this tech to him. So speaking of Garrett, you've done a transradial fitting and a transhumeral fitting. Can you kind of walk us through your fitting with Garrett?
Yeah. First, I'd like to make the qualifier that I was not the one that built the 15-pound sledgehammer. Garrett welded his own socket together, so he's definitely always kept us on our toes. I made the 3 or 4 pound one, so I feel more comfortable with that. But yeah, Garrett was my. I'll be very open and honest. Is my experience in prosthetics. I see a lot of our prosthetics, or our bionic prosthetic and orthotic group. I'm based in Northwest Indiana, just outside of the Chicago area, but I help with a lot of the cases across the country for our group. But my specialty up until really the last year or so has been more on the myoelectric side. So working with Garrett, I got to learn a lot of the challenges of body powered, and really he pushed me to my limits and on my thought process and how we can go through it. With Garrett's socket and at least the initial trial of the Gem hand, it really was a pretty seamless transition. We were able to swap him from his work hook to the Gem hand really quickly. The only minor change that we had to do with Garrett was move his proximal base plate retainer a bit more proximal and I don't know, towards the elbow, kind of towards the elbow, whatever those anatomical features are, to get the right line of pull for him. But one of the immediate changes I noticed was the force difference that he needed, because whenever Garrett would come into our clinic, he would just try and break the cabling as fast as he could to prove that he needed bigger and stronger cabling. But we were able to, he was able to get all the force and grip strength he wanted out of the hand without having to take our harnessing system to its extremes to try and meet his functional needs. Also in the cable line, we found, I guess in both these cases side by side, that having a cable approach that runs a bit more lateral than traditionally, or I guess on the, if they're in the thumbs up position, yeah, I guess that would be on the lateral side, gave us the best operation. It really minimized the amount of excursion that they had to utilize as well as force. And then thinking about this transhumeral case, I wish I had an anterior picture on him, but up until this point, I had really treated him as a shoulder disarticulation because he might have a 1.5-inch humerus. And We had some success with myoelectric, but when you're dealing with myoelectric and a shoulder disarticulation, weight and socket fit are very important, and any shift in that can cause, misalignment or misfiring of myocytes, or any daily volume fluctuations really proved to be a challenge for this user, where he was to the point of almost abandoning prosthetics when we decided to try the body powered system. And anyone who's fit these super short transhumerals knows that force isn't necessarily the problem, but excursion is. So we tried several options. We tried some voluntary opening hooks, some voluntary closing hooks, and then we tried the gem hand. And for the limited amount of, he could probably only get, I think from my call with Jerry Stark, who helped me through this case, you need about 4 to 5 inches of excursion. Don't quote me on that. I haven't taken my exams in quite a long time. 4 or 5 inches of excursion to be able to operate elbow and hand successfully. He only has about 1.5 at the time we started rehab with him, and he was able to get functional grip patterns with his gem hand on day 1 of usage, which was a great thing, because he was worried about it, because he does have function with his myo system, but the weight of it was always an issue. And we're excited to see him getting these outputs, and taking him from a user that maybe used his prosthesis 2 hours a day, where he's up to 4 to 5 hours a day. So he feels better about his body image. He feels his back pain is reducing. He's using it just for daily tasks like walking on a treadmill, or supportive functions when he's cooking or whatever it may be. But he's having such a great outcome now that we're really excited what the next couple of months are going to look like for him.
Awesome. Well, one of the questions I was going to ask you, Tony, as kind of a follow-up to both of these fittings is, what would you do differently? But sounds like now you're going to be doing that with Garrett because you've got approval. So congrats on that.
Thank you.
So what changes would you make? I know we kind of retrofitted and worked to set this up that way, but what changes would you make to really optimize this for Garrett moving forward?
I think because of the less amount of force that he has to utilize in the system, I think we can give him a bit more range of motion in the socket. We're not going to have to come up as proximal for him, because it's just not going to be as heavy duty, I guess, heavy use from his body side to control it. So I think you can kind of get a little bit more liberal with your proximal trim lines, as long as you have the control there to take care of it. Cabling wise, with both these systems, I really had not used Spectra cable before. But I found such an awesome application of it. So they're definitely both going to go to Spectra cables. It does take away some of that coefficient of friction in the line as they're trying to operate it. So if I can, my goal for Garrett moving forward is the least amount of body motion to operate that harness and get the function that he wants to do. So he'll definitely keep us on our toes with how he wants his harness designed, but he, it's going to be a fun experience. It always is with him. And maybe we'll do some nice internal cable design or something like that. But I also have to remember that Garrett likes to break everything. So I kind of got to take all that into account as well.
Yeah, excellent. I think, in the effort of time here, we want to be mindful of everybody's time. One question that's always on everybody's mind we get during every meeting is about reimbursement. So you've successfully submitted this, and it is a 7499 code. What is your advice? If you could give one piece of advice, what would it be for getting paid for this newer system on the market?
Really understanding the medical necessity of whatever device you're going to provide for your patient. A lot of manufacturers do a great job of telling you all about their device, but not how it's necessarily applicable to each specific patient. But when you sit back and really, really write that story or tell that story of how whatever they're utilizing currently, or maybe if they're not using anything, isn't meeting their unmet functional needs, and how this specific device can really meet those functional needs. And then a little snippet of how I was able to get one approved for Garrett is he's a workman's comp type claim. We claim that this device has equivalent function to the L6880 code, which is a standard myoelectric hand code. And we utilize that argument to say, while the technology may be different, the functional output is the same. And if we can get him to utilize his prosthesis more in more ways, it's going to be better for him down the long run.
Yeah, absolutely. And that's interesting. That's, we're going to be learning a lot more of this as we move forward, and best ways to code this. So, really appreciate being able to learn from you as a trendsetter here. So.
Well, thank you. And, for everyone on the call, I'm an open book. Our team has a lot of success battling some of these technology claims, some of these 9.9 code-based claims. Always feel free to reach out to us. We have a great process, and we're always happy to help guide along the way.
Perfect. And we can certainly supplement that on our end. We have some really great reimbursement support materials. I know those were helpful as guides moving forward. I know we only have a few minutes left, but Phil, maybe I pass this back to you if there's any questions that we want to address here, and yeah, go from there.
Yeah, awesome, Erica. Thank you so much. And Tony, thanks so much for joining us today. It's been really great to hear, from see your patient as well as hear from you how you got there. So there are a couple of questions I see Fergal's been answering as we go through. There was one in the Q&A from Ingo Knie, who was saying, does the hand have a small hand grip to put on a jacket?
Sure, and I can address this one. Hi, Ingo. Thanks for writing in there. So with the way the thumb works, when that is in that lateral position, right, I think when you're talking about putting a jacket on, that thumb sticking all the way up in the air would get caught, in a jacket. If you have that thumb all the way in that lateral position and you push it down, it will stay down a bit lower in order to be able to pass through a jacket sleeve. So kind of getting in your small hand mode, if you will, to be able to don a jacket easier. And a really great tip that I learned from several OTs in my time in this field is to put a plastic bag over the hand also. It'll help it slide through any material.
Yeah, great. And I think that Fergal's been busy on the chat, but there's the key question I think you just answered, Fergal, about the load carrying capacity or the break strength of the device, which is pretty impressive.
Yeah. So the load capacity, there's not one single load capacity, but if you're asking about how much it can carry, then 50 kilos, 110 pounds. And we can post the full technical specification alongside the pack after this meeting to everyone, because each finger has extremely high load capacities. The whole device is aircraft aluminum that's then hard anodized, because we wanted people basically to be able to go from a hook to a hand and not have a lot of the same concerns that they would have with, say, other multi-articulating devices.
Yeah, great. Well, miraculously, we've arrived at the half-hour time, and we managed to stay on track. So, thanks so much for joining us today, everybody. Just a reminder that Metacarpal Gem is now in the market. We're only focused on the USA at the moment. So, do please consider patients that are candidates for this product in your list. We'd love them to trial the Metacarpal Gem. As you can see, users are fitted now, reimbursement is happening. So obviously we'd love to bring this product to your clients and obviously help them with the transition to increased functionality. So thanks to everybody for joining us today on our panel, and appreciate you joining us over your probably your lunch break. And yeah, watch out for our website because we'll be doing more webinars as we go along. So thanks again, everybody, for joining us. Really appreciate it.
Thank you. Thanks everyone for joining, and thanks Tony as well.
Thank you, guys.
All right. Have a lovely day.
Bye-bye now.